Okay, for this video I wanted to go through this sample problem here about how to calculate the frequency of a photon given a wavelength. Okay, so this is just a kind of a straightforward sample problem here. Okay, now on this side what I'm going to do is I'm going to, if I can, right, I'm going to I'm going to write the given, okay? And so we are given that the wavelength, which is symbolized lambda, is 434 nanometers. Now, problem? That's right, it needs to be converted into meters. So we have to remember our conversions, our unit conversions, right? And so we go, we want to go 434 nanometers, X line. We put nanometers on the bottom, meters on the top, and we go 10 to the minus 9 meters is 1 nanometer. And that means that lambda equals 4.34 times 10 to the minus 7 meters. What else are we given? Well, we're not given the frequency. That's what we're trying to find, okay? But we know that C is equal to, because it's a constant, 3.0 times 10 to the 8th meters per second, okay? So the formula that we want to use is C equals nu lambda. Now what we have to do is just, I say just, but what we have to do is plug in the values. So what's C? Here, I'll write it in a different color. What's C? C is 3.0 times 10 to the minus, or times 10 to the 8th equals frequency we don't have, and then what's wavelength? Times 4.34 times 10 to the minus 7 meters. Okay, and this is in meters per second. Okay, so now we want to solve for just this guy. Okay, so that means we have to divide both sides by 4.34 times 10 to the minus 7. So that makes this cancel. And now 4.34 times 10 to the minus 7. Now we do math. Okay. And you plug it into the calculator, and when you do that, you get 6.91 times 10 to the 14th. And now what's the unit for frequency? Okay, I'm going to say 1 over seconds equals nu. Okay, there it is. Okay, do we have the right number of sig figs? Yes, the number in our problem has 3. This has 3. There's our answer. So there's your sample problem on how to solve for frequency given the wavelength.